Another day, another chance, another way, another dance. Today I'll be going over Pilot Crash Course 3rd Edition, Chapter 15 to 17, and yeah, I'll pretty much be deducing everything that I need to do. So yeah, let's get into this and let's go, man. So learn how to generate data sets and create visualizations with Matplotlib and Plotly. You practice making simple plots, scatter plots, and you explore random walks and histograms to analyze dice rolls. You then moved on to working with real-world datasets, processing CSV and GeoJSON files, and plotting data such as historical within geographical information. Next, you explored APIs to gather data automatically. Using the requests package, you worked with GitHub Hacker and used APIs and customized visualizations in Plotly. Overall, you develop skills to generate your own data sets, process and visualize real-world data, CSV, JSON, GeoJSON, and gather live data from APIs and visualize it. These skills prepare you for the next step. Building a web application with Django is the final project. Do you want me to make the short bullet? Yeah, so that's pretty much it, man. So presenting and visualizing real-world data, and yeah, that's what it is, man. That's pretty much it. So let's get to it and let's go. Right. So let me start with so as you can see here, I pretty much switched on my virtual environment. So that's what I pretty much switch it on, and yeah. Yeah, so let me go to my first one, my first file, Python EQ explore data. So as you can see here, from Matplotlib, you can import a path right there. You can import JSON, read data string, convert to a Python object. Path equals path, brackets. So we got right, content equal path dot read underscore text encoding UTF 98 old underscore EQ underscore data equals JSON dot loads and content. So that's what you've got. So what you've got here is a variable, and then you got a class, right? Then you got a variable, another variable, and then you got a method, right? With its parameters encoding equals UTF dash 8 variable, module function variable type variable. Yeah, I mean variable. So you got a for loop. So for EQ diction, all EQ dicts, right? Mag equals EQ dict. So this variable is going to lead to this variable, then got its properties. Same thing there. Then we're appending values to max, which is mag, for lines append line, and lat append lat, prints mag 10, print lines 5, lines 5. So obviously all of this information leads to what we see here, as you can see. Same thing here, we're gonna pretty much from Python so we're gonna use an import statement, an input JSON, input plotly.express spx, path equals path, eq underscore data, eq underscore data underscore 30 underscore day underscore m1 dot geojson, and context path dot read underscore text encoding utf dash 8, all underscore eq data JSON that loads contents, examine all earthquakes in the data set. So this examines all the earthquakes in the data set. So this type can equal to this variable with this along the string. So you got these variables, and then what they do is they're gonna get looped into this for loop, right, in all EQ dictionaries. So mag equals, so variable equals that variable along the strings there. Strings, variables that you got here turn strings, in case and square brackets into strings. EQ title equals EQ dict, properties title, max out append, so you're gonna append a value mag, append line, append lat, EQ title dot append, EQ underscore title equals global earthquakes, fig equals pig, scatter underscore geo, lat equals lats, so this variable equals that variable, and so on and so forth. So on and so forth. I wonder if you guys can hear me properly. Okay, so Python EQ underscore world underscore map dot py. So as you can see here, this was for like a world map of like global earthquakes. So as you can see, we got properties, geometry, and coordinates as well. So, so as you can see here, you got coordinates, mappings, geometry, you got all right, everything here, man. So yeah, that's what we've got. And then on to our CSV file format, right? So let's go to CSV files. So before I carry on, for my mapping global assets, the data just showed you, I created like a virtual environment. As you can see here, I created a virtual environment, right? That you can see there. And then like all the data that you saw is actually from here, from EQ data. So that's where it comes from. So that's what you got here. So all of these properties go into making sure that the data that it showed you, the framework for the data gets full properties and values, you know what I mean? So yeah. So, what? So as you can see here, what we do is so from Patlib, we can import path, input CSV from date time, import date time, and then import Matplotlib and pilot as PLT. So as you can see, we got path equals path, our variable equal our class, and our class with a data death valley underscore 2021 underscore simple.csv. So our variable equals to this variable that read underscore text, which is our method, then dot method. So we got a variable which reader equals module csv.reader function. So you got header row variable equals function variable. Extract dates and high and low temperatures. So dates, highs and lows. Then you got these empty square brackets. Then you got a for loop. All right, we got actually got a whole argument. So for loop, right, for row in reader, current date equals date time dot strip time, variable equals class dot strip time row two, and then you got try high equals integer row, square brackets 3 low equals integer row, square brackets 4 accept value error, printf string, right, and then you got an else statement. Date start append current date. So these are the variables. We got the method, variable, plot the high and low temperatures, plot that style. So you got these modules, plot that style, that use, seaborn, fig ax equals plt, that subplots, x dot plot dates highs, color equals red, alpha equals 0.5, x equal dot plot dates low color blue, alpha 0.5 x full underscore between, dates highs low face color equals blue alpha dot one, title equals daily high and low temperatures, 2021. You got this white space. What this white space does, it takes everything like Death Valley, California, and actually drops it down. So as you can see here, Death Valley, California has been dropped down because of you know the white space. So x dot set underscore title comma font size equals 20, fig dot out of fmt x date x set underscore y label temperature f font size equals 16, x dot tick parameters plt show. This is everything that you saw here gets exemplified there. Gets exemplified there. Oh, shit. You know what I mean? So that's what it gets. So yeah. So that's where it gets missing data for a while, okay? So as you can see here, you got the same thing here. So this is like a recurring pattern, in regards to like what we have. So we got a path variable. So we're gonna import values. So we're gonna import these values, path that read underscore text, same thing. Reader, CSV, next reader, header row, dates high lows, for loop row reader, current dates high, low, dates that append, highs that append, lows that append, dates time, plt dot style dot use, fig ax equals plt dot subplots, ax dot plot dates highs, color equals red, alpha equals O dot 5, x dot plot dates lows, color equals blue, alpha dot equals 0.5. So you got plots, right? Fill betweens, set title, set x label, auto format x date, set underscore y label, tick underscore params, then plt show. So that's what you pretty much have, man. I'd cancel that. Okay, so as you can see here, as soon as you quit there, you immediately get out, in regards to like, so same thing there, man. Yeah, same thing there. So what I just discussed just now gets simplified here: daily high and low temperatures. So temperature Fahrenheit, daily high and low temperatures, title, labels, temperatures, label size. And then you got highs, right? So you got imports, froms, then you got a path. Pretty much the same thing as I discussed, except the data is gonna be different. You know what I mean? So same thing here. These are the append current date, highs that append high, plot style, etc. Axes, daily high temperatures, seaborne, plot style, use seaborne. So obviously seaborne is an app that we use for plotting, the stuff that we've got, you know what I mean? So yeah. So Python sit underscore highs dot py. So yeah, so we got in row 4 rows, you know what I mean? So we got 4 rows. So that's what you've got, man. High dates highs. So pretty much everything you see here, I mean, it's pretty much the same thing. It's actually redundant if you ask me. In regards to everything that's going on here, it's quite redundant in the sense that, yeah, sorry for dropping the S bomb earlier on. I wasn't meant to do that. Apologize that. Lord forgive me. So as you can see here, all this stuff that you see here, is pretty much a repetitive cycle of what we had before. You know what I mean? So yeah, that's what we're dealing with here. Moving on to like data science. You know what I mean? Move on to like data science, and then let's do this. Let's rock and roll, baby. Let's rock and roll. So you got data env. So you're gonna import plotly.express as px, right? So let's run this first in the terminal. Dice score visual underscore d6 d10 dot py, right? Man, fuck. Oh man, what's going on around here, man? What's going on here? As you can see, the dies that we've got here, right? So we got die equals one, die underscore one equals die underscore two equals die 10, results equals, empty brackets for loop, row number and range, 1000 row equals die underscore one, row, empty brackets plus die underscore two dot row, results dot append result, frequencies equals square, empty square brackets max result equals die underscore one, dot number underscore size plus die underscore two dot number underscore size underscore results range. Right, brackets max underscore result plus one, for loop for value in pass, so results frequency equals results dot count value. So this variable equals to this variable along with the method frequencies dot append, right? Title equals results of rolling a d6 and a d10 50,000 times. Labels x result, y frequency of result, then figure px dot bar, x equals pause underscore results, y equals frequencies, title equals title, labels equals labels, fig dot update underscore layout, x axis dot d tick equals one, fig show, and stuff. So that's what you have here, man. And what just happened here, man? What's happened? What happened? Man, what happened? I hate to have it. I hate to have it. Me, hate to have it. So, as you can see, you can pretty much recognize a pattern here. Imports from statements and for loops, figures, axes, titles, labels, figures, So create a D6 and D10 mix and rows, so results in a list, analyze the results and visualize the results. So that's what you pretty much have. Mm. Wow. Same objects here. I'm just debugging the code. So we got die, results, for loop, results, man, uh, pending results, result equals one. So as you can see, I just debugged the code. You know what I mean? And it's pretty much the same stuff as we did it before. So let me just pause debugger. So as you can see, it's same thing. Same thing for die. Alright, so you got a class, right? Def, role, etc. That's what you've got. So you got an article.py, write requests, etc. So as you can see here, this one we got top stories. So what HN submissions does is import from operator, imports item getter, then imports requests, make an API call and check the response. So you got URL r equals request get URL print if string says code stays underscore code submissions underscore IDs art.json submission underscore dates equals empty square bracket. So that's what you got, right? So this is pretty much what we have here. So it's got a for loop, right? Process information about each submission. So submit. So this processes makes an API call and check response. Makes an API call for each submission. A submission dictionary, right? Submission dicts. And then we got a for loop there. Import matplotlib.pyplot as plt variable equals 12345 squares 149 16 25 plt.style.use seaborn version. Then you also got our axes, figures, xplot, tick params, plt show. You know what I mean? PLT show. That's what you got. So what you shown here is what you see here. You know what I mean? So that's what happens, man. So yeah. So MPL squares. So we got input matplotlib plot as PLT, right? So that's what you got. You know what I mean? So that's what you have here. You know. So yeah, same thing here. Got axes, plot style, got chart axes, title, X label, Y label, parameters, label size, PLT show, and yeah, that's what you've got, man. So this is actually what we've got. This this is from what we have here. So if you can like run debug, So this is Matplotlib tools. So you're pretty much debugging the tools that we've got here. Oh wait. Oh, you know what happened? I was running the code whilst I was debugging the code while I was running it. That's what happened, man. Good man. So that's what you've got here, man. So obviously ChatGPT picks up API request, process results, creates visualization. So this is what it's got, headers and shit. I mean headers and stuff, you know what I mean? I need to swear, man. So what you had before, same thing that you've got here, man. Got a for loop, print f strings, print says code. So what this does is it runs all the info that you got in your repository runs it. So it runs like your Python repo. So it makes an API call and checks the response, converts the response object to a dictionary. So it's got your f strings, right? Headers, URLs, explores information about the repository, and then prints user white space, takes everything and moves it over to the next section. There's a for loop, it printed all these f strings. Repo dictionaries, name owner, login, start cases, underscore count, HTML, underscore URL, create, underscore add, update, underscore add, description. So that's what you've got here. So you got from random import choice, classic random walk, class generates random walks, def init self, number of points equals 5,000, initialize attributes of your walk, self that number underscore points. So it's pretty much the same thing, man. Yeah. So you got a method that initializes attributes of a walk. All walk start at 0. method, calculate all the points in a walk. Keep taking steps. I will walk reaches the desired length. While loop decide decide which direction to go and how far to go. Rejects moves that go nowhere, and then calculate the new position. Yeah, I mean, yeah. So that's what you've got here, man. So yeah, it's like that's what you got here, man. So this is a cakewalk to me, brother. Okay, we got random walk. Let the pilot as PLT random underscore walk, import random walk. So you got a while loop, right? RW equals random walk, 50,000. RW equals full underscore walk. Plot the points in the walk. Um, uh, comma x equals PLT dot subplots point numbers equals range. X scatter x dot set underscore aspect equal x dot scatter. So what this does is keep making new walks as long as the program is active, make a random walk, plot the points in the walk, then emphasize. So what this does is emphasize the first and last points, making use of axes and methods, moves the axes with the methods, shows, and then you got if, keep running, should equal operator, end, break, keep running equals input, make another walk, yes or no. So these are like walks that you take and make, bro. Be you. Be you. Thanks. Yes. Okay, then we got one more. Right. So what we had before, with our plotting, set chart title, label X, set size of tick labels. So we've got X values and Y values, plot styling, set charting titles, set title label, set size of tick labels, tick underscore params, set the range for each axis, X dot axis, X dot tick label underscore format style equals plain plot dot show. Yeah, so that's what you've got, man. So scatter underscore squares. So all of these, like before, are gonna lead to what we got now. Square number, square values, and etc. So yeah, man. I mean, what more can I explain, man? Yeah. I mean, that's all I have to explain. You know, unless you want me to debug this stuff. Debugger. So that x values equals range 1 comma 1001. Y values x, dot ti- x to the power. So every time you see these two asterisks after a value, it means to the power of any number for x in x values, right? So as you can see here, you got a value. So this value gets carried over to y values underscore values. So x values equals range 1 comma 1001. Plot style that use, it's going to be using Seaborn's an app, for plotting. Figure x equals plot dot subplots x dot scatter x values y values c equals y values cma p equals plt dot cm dot blues, all that stuff, you know what I mean. X dot set title, square numbers, x dot set x label value, x dot set y label, tick params, x dot axis, x dot tick label, score format, plt show. I mean, dare say more, man. Dare I say more. So yeah. So and as you can see, you gotta adjust it here to make your adjustments, and then yeah, that's what you've got. You know what I mean? So yeah, I mean, what else can I explain? So that's pretty much and as you can see on your bottom right, you can see the coordinates there. So yeah, man. So thank you very much for being with me in regards to like this session. Take care and the Lord bless, and I'll see you on next time. And the person that I've been working with, for this project, is Aidan. You know what I mean, as a navigator, you know. I mean, Aiden's a pretty amazing guy, I like him, He's a great guy to work with, very humorous, very exciting, So it's Aiden, it's my navigator for this tutorial, you know what I mean? So yeah, uh you might get another video with him, as a navigator. As for this video, he was navigating. So yeah, thanks, man. Appreciate it. Take care, bless, and peace. navigate my next one.